science, biological engineering. Yes. Good. And so Jay is going to be talking to us, and I don't want to steal his thunder here, but a project called Field to Faucet. So this is a lot of the fantastic work that Ohio State University is funding, specifically the College of Food, Agriculture, and Environmental Sciences, related to harmful algal bloom issues. And so there's some great projects under here. But Jay's appointment in this Field to Faucet program lie within a larger program called the Global Water Initiative, or the GWI. And so Jay's going to give us some insight into that also. Just really to talk about all the great work that OSU is doing to address the water issues here in Lake Erie, but also, as the name implies, globally. Bachelor's from Purdue, master's from University of Florida, and then Louisiana State for your PhD. Right. And I don't want to take too much of your introduction because we're laying behind here, so I'm going to let you go. If you could do one thing for us that we usually do for the students, if you can, kind of give them a glimpse of where you started and how you got to where you're at. What we drive home with some of the students that are up here and they hear, you know, in our Thursday lectures is that people that are at a stage in their career like now, what did you do to get you to that position? So if you can kind of give them a little glimpse into kind of your path to where you got, that would be great.
Okay, should I start with that?
Please, if you could.
Okay. Yeah, so as Chris said, my undergraduate was at Purdue University, so I grew up in Indiana. I'm a Hoosier, as we talked about last week. Grew up in Indianapolis, and initially wanted to design race cars. I'm a race fan, so I went to Purdue University and started out in mechanical engineering, and did not do so well in my dynamics classes, but I always liked the environment and did do well in structures and things like that. And I switched to civil engineering, and then environmental engineering was in civil engineering, so I really liked that. So I got an undergraduate degree in, it was just civil engineering at the time, but it was environmental focused. And I was kind of on the track to either design sewers or to design wastewater treatment plants, and because I had some internships in a construction firm designing sewers. So I could have gotten a pretty good job out of my undergraduate doing that. Luckily for me, I think, I took some classes in ecology my senior year, wetland ecology actually, and really enjoyed that. And I was becoming more scholastic at that time after my earlier years of college, and decided to do a master's in ecology, systems ecology at University of Florida, and developed some wetlands of nitrogen cycling and treatment wetlands, how to use wetlands to remove nitrogen and improve water quality, and really enjoyed that. And then my PhD was actually in oceanography at Louisiana State University, and then I became more of a systems modeler. I did work looking at cellular models, so linking together hydrodynamic models that were developed by civil engineers at the Corps of Engineering, linking those together with ecological routines, that I developed or developed with people in oceanography to look at how does salinity affect different types of vegetation or fisheries. And so the questions we were trying to answer was, depending on how the Corps of Engineers manages the Mississippi River, they can direct so much of it towards New Orleans, they can direct so much of it further west than that. How does that affect land loss? How does it affect fisheries? How does it affect vegetative communities? So it was a roundabout way. I really did some things I enjoyed, and at that time there was a field called ecological engineering, which was starting to take off. And unbeknown to me, I kind of prepared myself to go into that field, and I really enjoyed what I was doing. And then about the same time I graduated, Ohio State was looking to advance its program in ecological engineering, or really start a program in ecological engineering, and I was hired into that. So that's how I got here. So that's what I did for about 15 years until recently. I taught classes and did research in that area. I've done a lot of research over the years. The thing that was a little strange to me initially, as Chris mentioned, I'm now in the College of Food, Agriculture, and Environmental Sciences at Ohio State. I have been, and before that I was never in an agricultural college. I was in oceanography or engineering or ecology. I forget what college I was in at Florida right now. And it doesn't matter, but it wasn't the ag college. The ag college is a little strange, but very applied stuff, which is good. And I ended up working with a lot of manure projects, looking at how do you improve water quality from farms, and I was turning manure into methane. But I always had some project involving Lake Erie throughout my whole time, and over time I became more focused on Lake Erie. For the last 5 or 6 years, I've been leading a pretty large NSF project looking a lot at harmful algal blooms and how human behavior, farmer behavior affects water quality and harmful algal blooms. And then the dean of the College of Food, Ag, Environmental Sciences launched this program, and I was basically what I've been doing, and so he tapped me to lead this program. So over about the last year, I've switched into a half administrative role and kept my research. So that might be more than you wanted to know, but careful what you ask for.
No, I think, what you've done at the other, it's been great because you can show that your path was definitely not a straight path.
Yeah, I'm not designing race cars. I still do attend auto races, though, but that's about as close as I get.
Versus Roger, who was a guest speaker a couple weeks ago, you knew since you were 7 years old that you wanted to be a biologist. And so it just gives, I appreciate that because it gives the students sitting here in the audience kind of the idea that there's not one way to get to the end point. So
Yep.
Thanks for that, Jeff.
Yep. Okay. So yeah, I do want to focus mostly on Field to Faucet today, but as Chris mentioned, I also want to talk about the Global Water Initiative because the Global Water Initiative houses Field to Faucet, so I want to talk a little bit about that. So to get started, I'm going to just identify kind of 3 global water challenges that are facing our world today, and one of those is water supply. Here in the U.S., water supply is something we can take for granted, except when things like Toledo happened. But in other parts of the world, people often have to carry water and gather water, and this has actually been identified as the most pressing problem in the world by the World Economic Forum, so ahead of terrorism, ahead of global economic crises and things like that. So it's a very important thing that affects many people around the world. Moving on from that is coastal resiliency. So this is New Orleans in 2005, Hurricane Katrina. My wife would kill me. She's from New Orleans, but Hurricane Katrina. So as our coastal populations continue to grow as they are, as the storms continue to worsen, we have more likelihood of seeing pictures like this. And so how do we make our cities more resilient? How do we design them to adapt to situations like this so we don't have people standing in water and things like this is another challenge facing us. And then coastal eutrophication, we know a lot about this in Ohio with the harmful algal blooms, but this is actually something else that impacts areas around the world. The agency led by Lester Brown, World Watch Institute, thank you, they've identified 750 locations around the world suffering from coastal eutrophication or harmful algal blooms. So this is something that's happening across the world. We just have too many nutrients coming from upstream area impacting downstream systems. And so, as Ohio State becomes the land grant of the future, it's a great opportunity to address these global challenges, and that's what the Global Water Initiative is focused on, these 3 areas. And so what I'm going to do here briefly is talk about our efforts related to wells to wellness and coastal resiliency, and then focus mostly on Field to Faucet. So first on wells to wellness, we focused our efforts initially in Tanzania, and the reason we've done this is because the Ag College, I'm going to use that instead of saying College of Food, Agriculture, and Environmental Sciences. It's a little faster. The Ag College has long-standing ties with Tanzania. Right now we have a USAID project with Tanzania to develop programs with the university there, so we have long-standing ties in Tanzania. So within Tanzania, we have identified about 5,000 non-functional wells. So a problem that's happened a lot of times in Tanzania and other countries where they have problems with water supply is NGOs will go in, build a well, then they'll walk away from it. And then the people that live there don't have the capacity to fix that. They don't have the parts and the know-how. So it's not atypical for countries such as Tanzania to have many non-functional wells. So Tanzania, we've identified about 5,000 of those. We've scaled down a little bit to focus on about 135 of those that we kind of think are the low-hanging fruit, the ones that would be the easiest to get back up to speed. And then eventually we'll expand back to the remaining wells. And so just to show you that we are kind of off and running with this, a couple months ago, this is Professor Malacha from the University of Dodoma, and we signed a memorandum of understanding with him. You might notice Dr. Kara Whitaker is here. She's in the audience, and this is the Dean of the Ag College at OSU. So we had some heavyweights here and some leaders from NGOs working in Tanzania. So we have some good support for this project. And I'll also mention that on August 20th, we're going to have the Minister of Water and Irrigation from Tanzania visit Ohio State to further move along with this project. So this project's off and running. So for wellness, we're focused on Tanzania. Moving on to coastal resiliency, this is the I guess the baby of the arc of global water initiative. We haven't quite got as far along with this as we'd like, but withstanding that, we have gained external recognition. I've been part of a leadership team for UNESCO Coastal Resiliency Collaborative. A couple months ago, I was in the Netherlands and had a meeting with this group of the Coastal Resiliency Collaborative, looking at what are the challenges that face us across the globe, looking at coastal resiliency, and how can we move forward on those in a systemic way. We've also been invited to serve on a UN RISE team, looking at sea level rise and trying to address that. So while this is just getting started, we have been recognized externally and are moving along with it. That being said, I'm going to focus mostly on field of Faucet. That's what I'm more familiar with and what you all are probably more familiar with and want to hear more about today. So regarding field of Faucet, I'm going to talk a little bit about impacts of phosphorus in Lake Erie. So some of the impacts we know well, some we don't know so well. I want to talk about some of the projects that we've funded under this program of Field of Faucet. And then I want to end it by looking at how do we integrate across the research that OSU can do and the extension that OSU can do and collaborate with other groups to really take research that's happening in the field or with people out to make a difference to try to address water quality in the state of Ohio. So moving along, I think we all know about what happened in Toledo. This is the thing that made harmful algal blooms really important. For me, at a personal level, since we're talking about personal stories, when I talked about my research to my family, I would tell them I worked on Lake Erie and water quality and harmful algal blooms. After this happened, I could just say, I'm working on Lake Erie and harmful algal blooms. They'd say, oh, okay, I've heard of that. So it's, this is the event that made harmful algal blooms a nationwide story. It changed legislation in the state of Ohio and things like that. So this is probably the most well-known impact of harmful algal blooms by far. There are other impacts that are a little bit less known. Besides the drinking water ban in Toledo last year, there are also drinking water bans in Monroe, Michigan, Pele Island, Canada, and the year before in Carroll Township, Ohio. So I think one thing to be aware of going forward is that we're trying to do work in the field, in the ag fields, and I'm going to talk more about that here in a little bit. That's not going to happen overnight. That's going to take 5 or 10 years to make a difference to reduce the amount of phosphorus that's coming into Lake Erie and driving these blooms. So while we're doing that, we're going to have to be very vigilant about our drinking water systems so that situations like these don't happen again, because the potential is going to be there. And so that's something we have to be very aware of. Another impact on the aquatic system that's much less known than drinking water is the impact on the aquatic ecosystem. And this is work that's being led by Stu Ludson and others at Ohio State, and I have a role in this also. But what we're looking at here is the food chain being affected by the cyanobacteria. So the cyanobacteria is the bacteria that really drives, it is the harmful algal blooms. And basically, as we have more of the cyanobacteria, we have less of the good the good algae that fish can eat. And so the good algae is what drives the food chain that terminates in walleye or yellow perch that we like to catch and drive the walleye in Lake Erie. This is something we need to keep an eye on and try to determine how are these toxins getting into the fish? Is this something that's happening over the lifetime of the fish? Is this something that happens during the bloom and then is cleared from the fish later on in the winter? Those are questions we don't know yet. Is it something that's worse when you have a bigger bloom or a more intense bloom? We don't know the answer to that question yet either. So there's important questions to answer looking at the aquatic ecosystem. So that's one of the more kind of lesser known impacts of these harmful algal blooms that's important to realize. The other thing to realize is that this isn't something that's just happening within Lake Erie. This is happening across the state of Ohio. This is an image, it's a little bit outdated, from 2013, but here you can see more than 20 inland water bodies in the state of Ohio that are affected by harmful algal blooms that had issues for blooms, toxin, or no contact. So this isn't something that just affects Lake Erie. This is something that has an impact across the state of Ohio. Grand Lake St. Mary's is probably the poster child for harmful algal blooms. And one of the things that Field of Faucet tries to have is we're definitely focused on Western Lake Erie, but we're also focused across the state to try to look at these inland water bodies as well and improve water quality there too. Keeping that in mind, 2/3 of Ohio does flow to the south, and there it leads down to the Ohio River, eventually gets down to the Gulf of Mexico, New Orleans, we mentioned before. There they have a problem with hypoxia. When we look at this part of the country, we're mostly focused on nitrogen because nitrate is usually the limiting nutrient in saltwater systems. When we go back to Ohio and things flowing to the north into Lake Erie, we're focused on phosphorus. It's generally accepted that phosphorus is a limiting nutrient in freshwater systems. And when we drill down even more with harmful algal blooms in mind, we're really focused on dissolved phosphorus, or the phosphorus that's more readily accessible by these blooms. And so why do we have this focus on dissolved phosphorus? That's what I'd like to point out with the next couple of slides here. If you look in the top right here, you can see that the concentration of dissolved phosphorus in the Maumee River, while it declined from 75 to 95 in the last 20 years, from 95, it's gone back up again. Okay, so we're seeing an increase in dissolved reactive phosphorus over time. When you put this increase in concentration together with flat or maybe slightly increasing levels of Maumee discharge, you get increased loads or increased amounts of dissolved phosphorus being discharged into Lake Erie from the Maumee River. So I should take a step back at this point and say that the reason I'm focusing on the Maumee here is because the Maumee is what drives these harmful algal blooms in Lake Erie. The Maumee is the biggest watershed, not only in Lake Erie, but in all the Great Lakes, and it's pretty much widely accepted that the Maumee is what drives the harmful algal blooms in Lake Erie. So these trends are very relevant and very important when we talk about harmful algal blooms, and we're seeing this increase in the amount of dissolved reactive phosphorus getting into Lake Erie. And this is one of the reasons we're focused on dissolved reactive phosphorus. And to go a little further, we see strong relationships between the amount of dissolved reactive phosphorus, or in this graph here, it's called soluble reactive phosphorus, driving or a strong relationship between soluble reactive phosphorus coming into the lake or being discharged by the Maumee River and the amount of cyanobacteria or the size of these blooms in the lake. So this is work done by Doug Kane last year. Other researchers have found similar relationships, a very strong R-squared showing the linkage between the amount of Maumee River SRP that's discharged into the lake and the amount of cyanobacteria or the amount of harmful algal blooms we find in the lake. So it's a very tight relationship. That's why we're focused on dissolved reactive phosphorus flowing into Lake Erie. And this has led to some recommendations coming from the Lake Erie Phosphorus Task Force report about reductions of phosphorus coming into Lake Erie. So looking across this, my students and I, we always talk about a 40% level. If we look at spring total phosphorus, the recommended reduction is 37%, annual total phosphorus 39%, spring dissolved phosphorus 41%. So looking across that, it's roughly 40% reduction in dissolved phosphorus is believed to get us down to a level of blooms that we can live with in Lake Erie. And so while we're focused on dissolved reactive phosphorus, what's the source? Where are we going to look to limit the amount of phosphorus coming into the lake? Well, we need to look to agriculture. And if you look at the middle of this graph here, the reason we're focused on agriculture is because that's the dominant land use in western Lake Erie. So if you look at the tributaries flowing into western Lake Erie, 70% or over 70% of those are row crops, mostly corn and soybeans in the state of Ohio. So that's where the bulk of this dissolved reactive phosphorus is coming from over time. That's where we need to focus on. That's not to say we don't want to give up or neglect what's happening in municipalities, looking at wastewater treatment plants and stormwater, but the majority of our focus needs to stay on what's happening on agricultural fields to realize the biggest benefit. And just to remind you, in case you think this problem is going away, a week ago, Dr. Rick Stumpf and others were gathered here in the same room and released the forecast for 2015. And the forecast is for something that might be just a shade less than 2011, which was the record bloom, the worst we've ever seen. So likely that we're going to see another really bad bloom this coming year. So these problems are going to stick with us for a while. So I'm just going to take a little break now and summarize. So the points that should be in your mind right now are that harmful algal blooms they're bad, they're here to stay. There's some impacts we all know about. We all know what happened in Toledo. There's lesser known impacts. So there's a lot of importance to try to fix this problem, to reduce the size of these bloom events. To do that, we're focused on dissolved reactive phosphorus. And in order to get the biggest bang for our buck, we need to focus on agriculture. So that's the summary of what I just told you. So just so it sticks with everybody, I wanted to go through that. So knowing the importance of this, Field to Faucet is a new program that was launched by the College of Food, Agriculture, and Environmental Sciences last fall. And the timing of this was not a coincidence. It happened right after the Toledo event. So that really changed things. It changed my job. It started a new program here. There was new legislation in the state of Ohio. A lot of things happened. So Field Faucet happened. So what is the focus of Field to Faucet? What are we doing in Field to Faucet? We're focused on an end-to-end system. So what do I mean by that? What I mean is we need to focus on what's happening in the fields. We need to limit the amount of phosphorus that's coming off. We need to turn off the source of phosphorus, right? At the same time, we're looking at sustainable food, maintain our agronomic productivity while limiting the amount of phosphorus coming down. At the same time, we need to make sure that we have a safe water supply, that we don't have these drinking water problems like we had in Toledo. That's the end-to-end system we're focused on. We need to accelerate our applications. So we're doing a lot of research. There's research going on at Ohio State. There's research at University of Toledo. There's all kinds of research happening. We need to do the research, but we need to get the applications on the field, get the applications in the drinking water plants so they make a difference, to accelerate those applications. And continue to collaborate with other agencies and universities. This is a big problem. No one entity or no one person can solve it. So that's kind of the general approach of Field to Faucet. The one thing to keep in mind is that we're not starting from zero here. There's a lot of great expertise to build on, not only at OSU, but across the state of Ohio and across the Midwest. And these are just some of the areas that we have a lot of knowledge in and entities that have this knowledge. I have emphasized drainage water management here because I'm going to delve into that a little more deeply later, this idea of drainage water management. So we're going to hit that a little more in depth later on. But we do have a lot of knowledge to build off on. But we do need some more knowledge as well. So what have we been doing with Field to Faucet? So one of the most important things we've done is we have an initial set of Field to Faucet projects that were started in March of this year. Dean McFerrin started this by putting in $1 million into Field to Faucet. That $1 million is largely funding these 5 projects. So I want to briefly talk about what these projects are. The first 2 are focused on the field, what's happening on the agricultural field mostly. The first of those are field management applications. So farmers, when they apply nutrients, they apply variable amounts of nutrients to different parts of their fields. Having these apps will allow them to record what types of fertilizer, what rates of fertilizer they're putting on different parts of their fields, and what methods they're using. What we also want to do is get information about weather into these handheld applications so that they'll know when a storm is approaching and when they should or should not apply fertilizer to limit the amount of runoff they're seeing there. Building on from that is the idea of a data cooperative. So there's a lot of good information out there for modelers such as myself and other researchers to build on. There's a great layer of water quality that comes from Heidelberg University. There's a great layer of soil maps. There's slope maps. There's all kinds of information out there, but it's usually scattered. So if we could get this in one place, it would help the researchers. If we could get information about what types of agronomic practices farmers are using, it can benefit farmers, both agronomically. They can see what their neighbors are doing, how that's impacting their yields. They can also see how it's impacting water quality, and they might want to change a practice based on that. So this idea of having some data and information that's available to farmers will be helpful and available to researchers. The challenge here, and this isn't my expertise, but is to somehow keep this anonymous so that farmers are leery of this, about the OEPA or other agencies using this to pin them down and say, oh, you put on phosphorus fertilizer last week and we had a really high concentration here. So we need to balance out the good with anonymity there to move forward on this project. But there's people on top of that leading this project, and they got that under control. They will have it under control. Moving on to the faucet end of things, these next two projects are focused on developing real-time microcystin detection, so being able to detect the concentrations of microcystin in real time. One of the problems that was faced in Toledo last year and affects all the drinking water treatment plants is that they take a sample of water, they'll send it off for an ELISA analysis, and it takes hours to get that sample back. So they're trying to decide what type of treatment they're going to use for their water based on a sample that was collected hours beforehand. That makes it difficult to decide what to use. So if we could have real-time microcystin concentrations, it would be really helpful. The first of these is developing an actual detector that you could place in the water, so you could get real-time microcystin concentrations that way. That's being developed by a faculty member in the Department of Electrical Engineering at Ohio State. The next trial with this is using bloom detection with UAVs and drones, so actually using satellite information or drones to actually monitor the water and develop algorithms that can give you real-time microcystin concentrations that way. And the last project we're calling manure recycling. What this basically is stripping out some of the nitrogen and phosphorus before you reapply the manure to fields. This might not have so much application to Lake Erie watersheds. What we found in our surveys in the Maumee is that just about 10% of the farmers actually are applying manure to their fields. It's mostly synthetic fertilizer in these situations. But it has a lot more application to a place like Grand Lake St. Mary's, where there's an overabundance of livestock and, more importantly, an overabundance of manure. So if you could strip out some of that nitrogen and phosphorus before you put that manure back on the ground, it could improve the water quality. So that's the last project we're focused on there. Another important event that happened in the fall was what used to be known as the Ohio Board of Regents. Now it's known as the Ohio Department of Higher Education. But they put out $2 million to focus on harmful algal blooms. And with that, they identified 18 projects that started around the same time as the Field to Faucet projects. And these projects were picked to complement Field to Faucet. So these projects also look across the landscape from what's happening on the fields to the faucet. And just to give you an idea I don't want to describe all 18 of these, but just to give you an idea for the complementarity here, related to safe drinking water, the Field to Faucet project is looking primarily at what's happening in the lake, looking at the microcystin concentrations in the lake, whereas the Board of Regents or the Ohio Department of Higher Education project is looking at what's happening within the treatment plant, looking at developing better ways to treat the water in the plant, also asking questions about if microcystin does get in the pipes within the drinking water system, how long does it stay in the pipes? How long does it take to be flushed out? So that's the kind of complementarity we have between these different projects because they start at the same time. And Chris and I and others were working together to get these projects started. And so right now, Chris or I, we don't have the results from these projects. We're excited about them. But hopefully in the future we'll be able to talk about the results from these projects. What's important is that as these projects move forward, we stay on top of them, move them along in a timely manner, and get the results from them and get applications that can make a difference on the field. And so what I'd like to talk about now is some current research that's going on and giving an example of the integration of how research merges together with collaboration with agency partners and extension to try to make a difference. So that when we do get the results from Field to Faucet and Board of Regents projects, we have kind of a template for how we can make a difference. And to do this, I want to focus, as I mentioned before, on this idea of drainage water management. And I'm going to describe this a little bit more in a couple of slides here. But before I talk about exactly what drainage water management is, I want to take a step back and talk about why we have drainage within the Maumee Basin, why it's so important, and why drainage water management will make a big difference here. So when we look across the country, where do we have drainage? Where is the most drainage or most intensively drained land within the United States? Well, it happens to be within northwest Ohio and right in the hot spot of the watershed that feeds into western Lake Erie. Why is this? Mostly because this area, the Maumee watershed, used to be the Great Black Swamp. So it's a very poorly drained landscape. So if you want to have productive agriculture in this area, you have to drain it, or else your fields would be swamped. The rains that we've had right now, if we didn't have drainage on our agricultural lands right now, they'd be underwater. You wouldn't see any corn growing out there. On the way up today, there's corn that's way up above my head already. They used to say knee-high in the 4th of July. We're way beyond that, and even with all the rain we're having, the corn's doing quite well, it looks like. So anyway, drainage is really important to make this a productive landscape. This is the most intensively drained land. It is probably the most intensively drained land in the country. For those of you that don't have a agricultural background, what is drainage? It's basically putting pipes below the ground in agricultural fields so that when it does become waterlogged, the water will drain into these pipes and flow off into ditches and then eventually flow off into streams and rivers. So the way this works is you dig a trench in your field and you line it with what used to be called tiles. It used to be made out of clay tiles. Now they're made out of plastic perforated pipe. And you bury the pipe in these fields, usually line it with some gravel to keep the flow going better. And then these pipes will actually discharge into streams. If you ever walk along an agricultural ditch, you'll see these things sticking out, and that's the drainage tiles that discharge into these ditches, which must be maintained at a lower elevation than the pipes so that you can move the water off. And these things take the water to the river. So that's a quick synopsis of the importance of drainage and what drainage is. Now, the drainage water management. So one of the things that happens with drainage on agricultural lands, it's really effective at getting water off agricultural lands and keeping them from being flooded. It's also really effective at moving nutrients off those lands really fast and getting them to Lake Erie, which fuel harmful algal blooms. So what drainage water management does is tries to slow down the flow of that water. And it does that in a pretty simple, straightforward way by basically building a dam at the end of these outlets. So you put in these boxes. These are called drainage water management boxes, or we usually refer to them as boxes. And you put weirs in these boxes, and then you can back up the water level within the field. And so you can hold that water in the field and slow down the amount of time, or make the water take longer between the amount of time it hits the field and gets to Lake Erie. If a farmer, farmers do need to get on their field at certain times, need to drive machinery on there to plant or to harvest, you can open up the box, let the water out, let it dry out. You can drive your tractors on the field. And then after planting, you can maintain it at kind of a moderate level, and this will allow the roots of the corn or soybeans or whatever you're going to access that water. And as I'll tell you later, you can actually get slight gains in productivity from this practice as well. Some of the important work that's been done with this is USDA ARS. A lot of this has been done in conjunction with Ohio State. Norm Fauci, who's a scientist at USDA ARS, has led a lot of this work over the last couple of decades, actually. So talk about the research here of drainage water management. So some important things that are happening is the research, what we call edge of field studies. And Kevin King in the USDA ARS office affiliated with OSU has led a lot of this work. So he's doing edge of field research, so where he compares one management technique, in this case drainage water management, to a control, a very similar field that does not have drainage water management, and looks at the difference. So here you have two graphs at the top. One is the concentrations of dissolved reactive phosphorus without DRM or drainage water management, and with DRM. And you can see that there looks like there's a little difference here. He actually told me that this is not significant. There's no significant difference in the concentration of DRP that's coming off the tiles. It's coming off the. What is different is that there's a 65 to 74% reduction in annual DRP load. So what's happening here is these tiles, they're effective at holding back the water. So they limit the amount of water that's coming off the field. And just by limiting the amount of water, while you're not affecting the concentration of DRP, you're still reducing the mass of DRP that's coming off by 65 to 74%. So he's found this to be a really important practice, at least on this one field, over these 6 years he's looked at it here. So the research shows that this is important, and what's always nice is when a couple different studies find the same thing. So Lindsay Pease is a PhD student at Ohio State that I'm working with in conjunction with USDA ARS office, and she's also found that drainage water management makes a difference. So she found reduction in dissolved nitrogen and phosphorus losses via reduction in subsurface drain flow. So again, it's not the concentration that this practice affects, it's the amount of water coming off, but just by affecting the amount of water, you limit the amount of dissolved reactive phosphorus that's coming off as well. As I mentioned, another benefit that farmers might be interested in knowing is that there's a slight gain in yields that's seen with this as well, because during the drought we usually see in the fall, you can hold back that water on the field and keep it available to the plants. I didn't mention it specifically, but normally we're seeing about a 50% reduction in the drainage discharge, so 50% reduction in the amount of water that's coming off the tiles. So that's the research, the edge of field studies, and so we know it's effective looking at it from a research standpoint, but are farmers willing to adopt this? And so this is where the research about farmer decision making takes place. And so this is work that's being led by Robin Wilson and others in the School of Environment and Natural Resources as part of an NSF grant that I'm leading that I mentioned earlier. So we've done a lot of surveys of farmers within the Maumee watershed to find out how do they feel about different best management practices, and are they likely to adopt them or not, and why. And so what I've highlighted here is managing field water levels with drainage water management systems, and then this is the probability of adoption. And so what's important to note here is that over half the farmers are unlikely to adopt this approach, right? So we found something that's really effective, but it's a little bit alarming or not very helpful to know farmers won't adopt it. So why do you think farmers might not adopt it? It costs money. Each of those boxes costs a few $1,000s to get it in. Any other reasons? It takes time. It's money and time. So each one of those boxes, a farmer has to go in. If a farmer has 30 to 40 tile outlets, they have to go in and move up those tiles up and down. And that's exactly what we found when we did the surveys and we talked to farmers a little more in depth. It's money and time. So how do we get around that? Well, one of the things we've done in a collaboration with different agencies and partnerships to gather some funding is we've been successful in garnering this is a $17.5 million grant. It was a partnership across different groups from Michigan, Indiana, and Ohio, Tri-State Western Lake Erie Basin Phosphorus Reduction Initiative. Most of the money is coming to Ohio. I think $12.5 million is coming to Ohio, and this is cost-share monies. This will go in and help farmers pay for one of the practices is drainage water management, water control structures, and drainage water management. So this is getting money to help farmers implement these devices specifically. And then lastly is the role of extension. So OSU has an extension officer in every county. Sea Grant has extension officers in all the counties that border Lake Erie. So we're blessed to have a really, really strong extension network. So not only can we get the information out about how effective these boxes are, but we've also added some extension agents recently to help get farmers eligible to apply for the money coming from that tri-state grant. They have to have a nutrient management plan and things like that. So we've actually added 3 extension officers to get farmers up to speed on nutrient management plans and make them able to apply for that money. The other thing that's really important is the fertilizer applicator certification training. This is something that's was launched last year. It's a way to get information about different practices out to farmers. So we're getting information out about drainage water management boxes, about other ways to improve water quality. So that's just an example of kind of how we can integrate across research, field research, social research, collaboration to garner some funding, and then use an extension to get this information out to farmers who can use it. So Field of Faucet, next steps, just to summarize here, we need to manage these current projects to get results, continue to integrate across research, extension, work with other organizations to make improvements, work to generate future funding so that we not only have these 5 projects, but have other projects in the future that we can focus on, and then take the knowledge that we developed for algal blooms in Lake Erie back across the globe so that those 750 sites can benefit from what we learn in Lake Erie, but also we need to benefit from what's being learned at those other 750 across the world. So with that, I'm just going to mention we have a lot of great partners, of course, that we're working with, and thank you all for being here today, and thanks for giving me this chance to talk.
We have some time for questions. Any questions for Jay?
So Jay, with part of the collaborative nature that this really needs, how is Michigan and Indiana collaborating with you guys, considering their headwaters above you guys?
We're getting better connected, I would say. It's been Michigan. There's stronger ties, I'd say, right now than Indiana. So right now, actually tomorrow, I'm going to Toledo to meet with folks from the University of Michigan to look at different watershed models we're using within the Maumee watershed. So we have a model in the Maumee watershed. Michigan has one. Heidelberg has one. So we're looking at linking those together and seeing what's the similarities and differences of those models. So we have stronger relationships there right now. But this tri-state grant that I mentioned before was really an important way to start to pull together these three states, I think. So,
has Indiana contributed, could I ask?
Yeah.
So the state has put money into it?
I don't know if the state's put money into it, but they've put resources into it. So
okay.
in Ohio, Steve Davis was really important in NRCS, and then Joyce, can't remember her last name, with ODNR down in Columbus. They were really the leaders of it in Ohio. But each state had their own kind of state leaders of the program. So Indiana, I don't know if they put money into it, but they definitely put personnel time into it. And they actually did have to put some money into it, because one of the things that had to happen, you had to have a match. So we contributed some of the match from our NSF project. So I'm assuming that some of the match came from groups in Indiana and Michigan as well. So yeah, so I think Indiana's involved, and Indiana is doing some great work. So the folks at Purdue have some good projects in the western part of the Maumee watershed, looking at what's happening around Fort Wayne, St. Mary's River, and things like that. They have some SWAT models, some watershed models. Jen Tank is doing some work at South Notre Dame with some ditch work there. So yeah, there's stuff happening in Indiana, which is important.
Unfortunately, the one that you highlighted with the money that's going to farmers to implement some of these things, that roughly $12.5 million that's coming to Ohio,
yeah.
And there's some going to Michigan. Indiana wasn't in that. For some reason, something didn't happen where they didn't. I don't think they got it.
Oh, really?
Yeah.
Okay.
But there is still work going on the ground. But that was more like, I don't know, behind the scenes political kind of thing, where there was. I don't think there was agreement in the language about that.
Okay. Yeah. Yeah. Yeah.
So like for the fertilizers, the artificial fertilizers, are they liquid form or are they solid form? And then also, does it make a difference if you put manure on your field? Does that help better with the phosphorus?
So first question first. So most of the when you look at phosphorus, most of the fertilizers being put on as a solid form. And so one of the key things, now I wanted to work that in the talk, but I didn't want to make it too long, is this issue of broadcasting fertilizers. So they usually, what's done a lot within the Maumee Basin is broadcasting pellets of phosphorus fertilizer. Similar, if you're not familiar with agricultural settings, you'll see people fertilize their lawns by spreading pellets on their lawns. It's a bigger scale, but a lot of farmers do the same thing to put fertilizer on their fields. And when you combine that with no-till, which no-till is, you don't use any tillage, okay? And no-till is really good because it reduces the amount of sediment that's lost from farm fields. But when you combine that with broadcasting solid fertilizer and you get a big rain event, you get a lot of runoff. And so another practice that's shown a lot of potential to reduce the amount of phosphorus coming off agricultural fields is getting that phosphorus off the surface. So what's being referred to now is placing that fertilizer within the soil. So somehow you could either use the solid fertilizer like we talked about before, and then incorporate it with some minor tillage to get it in the soil, or you could use liquid fertilizer and inject it. They're trying to develop techniques right now to inject the solid fertilizer as well. Manure, you asked about manure, and does that help reduce the amount of phosphorus coming off the fields? I really don't have a good answer to that, how, if you use manure as opposed to synthetic, if that's going to make a big difference or not. It depends a lot on the timing and how you put it on, if you put it on the surface or not. So like I said, in my feeling and what we found in the surveys that I mentioned there before is that only about 10% of the farmers are putting manure on their fields in the Maumee Basin. So we don't feel like it's that big of an issue. There's 10% of the farmers that could represent 50% of the acreage, so it might be a bigger issue than I think.
Jim, with that, some of the answers up here, I know that some of the survey work is being done by other PIs, I'm granted. But when you see those numbers of farmers willing to adopt, I'm curious as if you're seeing differences in the answers when you compare old generation farmers versus younger generation farmers, and if you're seeing also maybe a difference in farmers that own the land versus farmers that rent the land.
Yeah, we see a lot of differences that have to do with age. The one thing that we do see that's heartening is that a lot of farmers we see have a pretty strong environmental ethic, and a lot of farmers, I didn't show this table up there, but a lot of farmers will say that they realize there's a water quality problem and that they have a role, that they believe they have a role in solving that problem or a role in addressing that problem. Most farmers, when you ask them, they just want to have confidence that whatever BMP that they implement on their field, that it'll work. Because they have to make sometimes a substantial investment in time or money like we talked about, but they just want to make sure what they do will work. So, yeah, we definitely see differences. We have all kinds of control factors for these surveys, so political party is a big predictor on these things, and other things you might not think about right offhand about what would influence your leaning towards different BMPs, but yeah, different farmer makeups you can use as predictive factors. And actually, one of the things we're trying to do is model farmer behavior to different incentive plans to see, okay, if a different policy was implemented, if there was an incentive to use drainage water management boxes, how many farmers would adopt it and which farmers would adopt it? If there was an incentive to if there's an incentive to place fertilizer within the soil, what farmers would adopt that? And by knowing which farmers are more apt to adopt this or that based on different ages and things like that, and we have an idea of the how old different farmers are and things like that, we can get an idea of who might adopt what type of policy. But that's an important thing that we're actually looking at.
So if you do this thing where you raise the discharge level for the tiles
Yep.
in your field, you hold back water, and that water's got phosphorus in it, is this going to cause phosphorus to build up to higher levels and could get to levels where it could be harmful or something to the farmer, and then maybe they get concentrate higher, and then they eventually finally get out of the field through the tiles. What's the long-term future of that practice?
Yeah. So one of the things we talk about with all these practices when we go back to no-till is unintended consequences, right? So we see it works in the short term, but there could be long-term unintended consequences. So I don't know the answer to that question, but some of the research that Kevin King's done with these edge of field studies does show some interesting things. So sometimes if you do have the drainage water management and you hold water back in the field, you might tend to get more surface runoff, right? Because the water has nowhere to go. And so some of this, and Chris and I were just talking about this a couple hours ago, some of the concentrations of phosphorus you get in the surface runoff are actually higher than what you might get in from the drainage tiles. So you got to be careful what you wish for, right? So you might be changing what's happening in the drainage tiles, but you might be getting higher concentrations of phosphorus coming off from the surface. Now, so that's one thing that's a little bit related to your question. I don't know the answer to your question because our research only goes back a few years on these systems. So how does it build up over time? I don't know.
Just getting started, really.
Yeah.
On this whole thing.
Yeah. But going back even further, this practice actually started in Iowa, and they've done a lot of work in Indiana, mostly focused on the Mississippi basin, trying to resolve the nitrogen problem. And so drainage water management is really effective there because you hold back the water, it's anaerobic, the nitrogen's gone, right?
Yeah.
So you don't have to worry about buildup problems. And so some of the work we're doing now in Ohio is some of the first to look at phosphorus with water quality. How does it affect phosphorus and DRP? But looking at buildup over time, that's a great question that we don't know the answer to yet.
But concurrently running on right now, not funded under FUF or the Board of Regents, is a work by Dr. Libby Tate, and she's looking at soil testing and how you should properly soil test your field, and then establishing and revising the current phosphorus risk index. And so concurrent with this, we do now have a better look at how you should be maintaining that. So I think we have a better idea to catch the rise in phosphorus because we're doing a better job of soil testing. So that's beneficial. So hopefully if we are going in the wrong direction with this, we catch it before it gets.
And then check it, so it doesn't keep going up.
Yeah.
Do you think with being able to actually hold back the water and possibly keep more phosphorus in the soil, that would eventually lead to farmers not having to use as much fertilizer anyway?
It could because you're making the water more available and you're not holding the water on the field longer, you're holding that phosphorus on the field longer, so it should make the phosphorus more available to the crops over time as well. So that could be another potentially good thing that could happen with this practice for sure. Yeah.
Right. If we could thank Jay for his I consider many bosses because I report to the stakeholders of Lake Erie and the people that call Lake Erie home. But as far as operationally, I report to the federal government through the National Oceanic and Atmospheric Administration, and then I report to two vice presidents at Ohio State University, Dean McPherron, that's at the College of Food, Agri, and Environmental Sciences, and then the Office of Research and Dr. Whitaker. And she has been so supportive of the lab in the research endeavors that we're under, and also the education programs that we support here. So those of you that have seen the water quality lab or that are working in that water quality lab, that was co-funded, the renovations of that and the equipment in that were co-funded by Carol's office and also the Ohio EPA. And so when we do renovations in this building and we try and make this building a place that is great for research and also learning, much of that support comes from the Office of Research. Received both her bachelor's and her PhD from Ohio State University, and then you did some postdoctoral work at Northwestern in Chicago in the Med College there. Your background actually, most of your research became, before VP, was immunology for multiple sclerosis, I believe. As a faculty member, very, very successful. I love to see University Distinguished Scholar Award in like 01, I think, and then 08, and then Distinguished Service Award also. So the University Distinguished Award, that was then 01. And then I know you're a fellow for the AAAS, so the American Association for the Advancement of Science. And then another thing that speaks volumes for Dr. Whitaker is that she sits on a lot of advisory boards for different important programs and agencies across the state. So I'm happy to have her. If you think balancing your checkbook is difficult, imagine being kind of overseeing and strategic planning for just under $1 billion at Ohio State University as far as research goes. So that's quite a chunk of money to understand how to manage that as a program and support that research. So it's impressive to do that. So we can welcome Dr. Whitaker.
Thanks so much, Chris. It's a real pleasure to be here, and I want to tell you exactly how much of a pleasure it is to be here because I'm walking my dog last night at midnight, and he gets sprayed in the face with a skunk. So I get to walk away, come up here, spend the night, not have to smell the skunk smell. So if you smell skunk, I apologize. It's kind of hard to get rid of. But my husband's dealing with that, so that's good. That's good. But I'd like to just expand a little bit on what Chris was saying in terms of the dollars that were available. Were really built on kind of the work Stone Lab has done in the harmful algal bloom area. And so who did the governor turn to when the water got turned off in Toledo? They turned here. They turned to Ohio State. They turned, Stone Lab, Jeff Reuter, Chris Winslow. And I think you should be very proud to be affiliated with this organization because you really have quite a reputation. actually in the harmful algal blooms area. So with that as an introduction, let me just give you a very quick research and review. I know you've been sitting here for now 2 hours and 15 minutes, so I want to make this as entertaining as possible. This is a very quick outline, and I don't think it's going to take me an hour because you have other things you want to do tonight. But let me just tell you some quick facts about research at Ohio State. I'm going to tell you some national trends actually in research and why it's good to be comprehensive. And you heard Jay talk about the attack that is possible on a big problem like harmful algal blooms. And that's not something that you can do just in one department or even one college. It really takes a multi-pronged attack to deal with something like that. So why is it good to be a big university? And the very important role of research partnerships. You heard some of this. I'm going to tell you a little bit more. Student projects. We have a lot of students in the room. I'm going to tell you about some really exciting student projects that actually have emerged. And then we need to talk about research in a different way. And I'm going to tell you a little bit about how we're going to do that. So I'm going to very quickly go through these topics. And as Chris said, this is the 10-year research funding profile at Ohio State, and we're bumping up against $1 billion. And this is what we spend on research. This is talk about research in two different ways: research awards, research expenditures. This is what we spend. And you'll see a curve like this for most universities in that faculty numbers have tended to grow. I'm not sure that's going to, go on forever. But faculty have gotten, I think, much more clever about how to go after research money. And so you see a pretty steady climb in terms of research dollars. So where does that come from? At Ohio State, it's a little bit different for any university, particularly some of the other universities in the room. More than half of our dollars actually come from federal sources. That's the National Institutes of Health, National Science Foundation, USDA. Ohio State's a little bit unusual with this wedge of the pie. Almost 20% comes from industry. Most universities are about 6 to 8%, certainly single digits. And we actually have quite a bit of relationships with, many of the companies around us, companies in Ohio. Half of our partners are actually from within Ohio. Half of them are actually from without. But if you had shown somebody this pie 10 years ago, they would say that looks awful, because 10 years ago this would have been the goal, to be 90% federal. That's the gold standard. And so, but think of what's happened in that last decade. Federal has tended to either stay the same or slightly decline. So we look very smart at this point to have diversified the funding portfolio to go from, primarily federal to mostly federal and industry as well. So who are some of those industry collaborations? You see that there's two different kinds of industry collaborations here. Honda is one of our big partners. There's engineering companies, and then there's pharma and biotech companies. So those are the two different kinds of partners that actually make this up. So what do the national trends look like? So where are we going in terms of research in this country? It doesn't look so good. So we hit a peak at about 1964. And so this shows the research, R&D stands for research and development, either as a share of the federal budget or as the share of gross domestic product. And so either way you look at it, it's going down. And so we're sort of at an all-time low right now for as a percent of the whole. If you look at the overall dollars, we're doing okay, but the overall dollars have actually increased. So as a percent of the whole, not doing so well. So I thought it would be interesting to look at the FY15 budget. We just finished, well, no, I'm sorry, not the federal budget ends in September. So we're still in the middle of the FY15 budget. $3.9 trillion, but the part in gray is really what we can't do much about. That is Social Security, Medicare, Medicaid, other mandatory programs, and the interest on the debt. So this part is really rather fixed and actually kind of growing. And so if you look at the parts of the federal budget that we can actually do something about, it's called the discretionary budget, and that's either the defense discretionary or the non-defense discretionary. So all of our research money is these two little wedges that are actually called out here. So there is research in the defense budget. Well, we also often think of the defense budget as just, sort of going to war overseas somewhere, but there is a wedge of research in there. And so if we take these two pieces of the overall research budget and make that the whole, what kind of research is funded federally overall? And we see that half of it comes from the Department of Defense, and part of it comes from National Institutes of Health, Energy, NASA, NSF, USDA, and some other smaller agencies. So that total nationally is about $136 billion that we spend overall. So on a base of $3.9 trillion, that's not a lot. It sounds like a lot, $136 billion, but on a base of $3.9 trillion is not a lot to really build the entire R&D budget of this entire country. So let's look at the trends in federal spending since 2010. If we put that at sort of 0% and notice what's happened since then, in the last 5 years, we've seen a pretty precipitous decline. This is NASA, which has had probably the greatest decline. The National Institutes of Health is right here, and there's actually bipartisan support right now for the National Institutes of Health, who it looks like maybe going to get an extra $1 billion or $2 put into their budget. National Science Foundation is here. Actually, USDA, which is probably what you care about most here, actually isn't up there. It's not any different in terms of the overall slope of these graphs. So research and development is not exactly thriving at this point relative to 2010. All right. So that's kind of the bad news at this point. So these are the challenges that any university research faces today, and it's, as we saw, it's an unstable and even declining federal funding and even state funding. I mean, you have these blips for harmful algal blooms, and you have blips in the funding at the state level, but by and large, you have decreases in things like state share of instruction going to universities. We have increasing compliance and reporting requirements. We have greater competition for the best faculty and students. And there tends to be, you may have seen this, a loss of public confidence in the value of university-based research. We've had some scandals come out. We've had, research that can't be reproduced. So the public is saying, what are you guys doing with our public money? All right, so this is the climate that we're actually dealing with in times like this. So sorry for the bad news, but I think it's really sort of the reality. So I want to ask the question, why is it good to be comprehensive in research? So you just heard a beautiful presentation by Jay Martin on why it's good to be comprehensive. And I wanted to tell you very quickly about a program at Ohio State to hire new faculty. It's called the Discovery Theme. And the goal is to attack big global problems like energy and the environment. So harmful algal blooms is nested in that discovery theme. Alternative sources of energy with wind energy, solar energy are nested in here. Food production and food security is one area. Health and wellness is another area. So the Board of Trustees, senior leaders of the university, and a number of groups had input into what these three areas would be. So these are really large buckets. So we're looking at hiring about 400 new faculty, about 10% of the of the overall faculty numbers in these three areas. And so what's different about this is that there will be some program management associated with this. So, I mean, we have a lot of experience hiring faculty, but there's not been people to really help bring those faculty together. So these program managers will be doing that. And there are some expectations around return on investment. Some of these faculty are really some star faculty, and so it will be, they're not inexpensive to actually bring in. So these are the areas of emphasis with the discovery themes. Data analytics is at the top, and that is the first area, which really sits at the intersection of those three circles. And data analytics is an area where there'll be 40 new hires in the area of data analytics. But if you just scan down through this list, infectious diseases, emerging and re-emerging infectious diseases is an area. Chronic brain injury, concussion, strokes is an area of emphasis. Personalized food and nutritional metabolic profiling to improve health. Global food security, huge problem. Sustainability. And finally, translational materials and innovation. And again, accelerating global sustainability. So if you look at these topics, they don't fit into a single department. They don't fit into even a single college. So you can't say, oh, that's food, ag, and environmental science, or that's arts and sciences, or that's medicine, because there are so many areas that actually intersect to actually attack and solve some of these problems. So I want to really reiterate a couple of things Jay said around the Global Water Initiative. So obviously, if we want to look for some of those pressing problems, some of those under the energy and environment discovery theme, water is a huge problem. I don't need to tell you that here you're surrounded by it, but the quality may be an issue. So in approaching the Global Water Initiative, that's what GWI stands for, a little different idea was brought into place, and it was called venture philanthropy. You've heard of venture capital, and you've heard of philanthropy, but if we look at sort of the old model of philanthropy, it really is sort of looking for a discrete project. It's kind of hard to scale, maybe inefficient use of funds. It's sort of reactive to a problem. And it's sort of a one-time donation style funding. This is what many of the development officers in our institutions now do. They actually go to corporations kind of with their hands out. So this kind of buys a one-size-fits-all technology, and you don't know whether it works or it doesn't work in the next 5 years. So we decided in this Global Water Initiative to try a new public-private partnership, and it's not unique to us. It's actually being tried, around the country. It is an integrated network of assets. And so it's not only Ohio State, there's many other universities involved, industry, non-government organizations, and agency partners working on water applications and solutions. So it's a global commitment to sustainability. So it's money from a coalition, and funding really only goes if the right solution is found. So actually the winning solutions are really integrated. So I think in the Global Water Initiative, this is a slide by Marty Press, and Marty actually did his homework here. So in approaching this Global Water Initiative, and you heard Jay talk about the 3 projects that are underneath that Global Water Initiative, we assessed the market opportunity. So this was done 2 years ago. We said, what's the market in this area? What's the gap analysis? What's the review of the really major global challenges? Because the last thing we wanted to do was to really go in and reinvent the wheel and to do something that somebody else had already done. So we contracted with PricewaterhouseCoopers to really validate the concept. How unique is this concept. For them to do the gap analysis and the relationship of GWI to other initiatives. So these are major philanthropic organizations worldwide. Charity Water, the Clinton Global Initiative, United Nations, World Bank, RIFE. World Business Council is a very influential organization. And so what they came up with was this GWI network of land grant partners. And so we've brought together a number of universities around the Global Water Initiative. And many of these are land grant, which means they give back to the states that they're located in. And so you saw this with Jay's slide. So these are the three projects. I'm not going to, Jay talked about it in much more eloquent fashion than I will. But the three projects were really found to be quite unique, quite necessary, and really grabbed the attention of those founders. So the rural water development talks about the Tanzania situation. Field to faucet, harmful algal blooms, obviously I don't need to reiterate that. Coastal resilience, and Jay gave the example of New Orleans and Hurricane Katrina. I want to spend just a minute on the rural water development project because it is so impressive. When you look at these communities in Tanzania where, as Jay said, there's 5,000 of these communities. Many of them have a well sitting in the middle of their village. But that well, might have been put there by an NGO. It doesn't work anymore. So some small part has broken. That well simply doesn't work. So what happens is the women in that community spend hours every day going to a well miles and miles away with, something on their head to collect the water. So they spend most of their day on foot traveling to get water and bringing that back. So what this project is doing is taking 100 of those communities and fixing that well and showing those people how to fix that well and to put that, put into production those parts that actually fail in those wells. So it's really, that's what's sort of gotten the attention of Clinton Global Water, Charity Water, the World Business Council. And so doing those as a capstone project, doing those 100, fixing those wells in those 100 communities, then others come in afterwards and fix the other 4,500 wells. So I'm very excited about this project because I think it's going to make a true difference in Tanzania. And we've got as Jay said, we've got the very high-ranking officials coming from Tanzania actually in a month to actually kind of seal the deal on this. Very, very exciting project from Tanzania. And here, this is the picture of one of these women who's washing her dishes in Tanzania. But I had to laugh at the Pepsi bottle that's very prominently displayed here. You probably, is this 2011? The algal bloom in 2011?
Stretching pretty far east.
So these are two examples of the Global Water Initiative. But think for a minute how far-reaching two projects like this are and how they don't really fit into a Department of Ag Engineering or a Department of Animal Science or something like that. They are much broader than any single department, any single college. So that's the advantage of the research comprehensiveness. The second example I want to talk about is shale. That's another very prominent example in the state of Ohio. We have tremendous resources in this area around shale. And here are the shale plays in the United States. And you can see that we're very fortunate to be home to one of the largest deposits of shale actually in the country. So Texas has quite a few. I don't know my geography well enough to know what that is. That's Montana, I know. That's North Dakota. I don't know what that is. Colorado, what's that state? Wyoming. Thank you. So if we look at, let's hone in a little bit on the Ohio play. So what made the news first was the Marcellus shale play in West Virginia and in Pennsylvania, and then pretty soon afterwards it was discovered that this extends far more east than we had realized into Ohio. So this is the Whitaker shale, and then Whitaker underneath Marcellus is really what's extending actually quite far north. So this is something we really had to take advantage of and to study, because remember some of the news reports about minor earthquakes that actually are happening as a result of, not just as a result of drilling, because remember, to get the shale out, you have to send a drill down, a mile down into the earth, and then it goes horizontal. So you are really shattering lots of areas of rock far underneath the ground. So there are these minor earthquakes. So one of the questions we wanted to ask was the environmental impact of this, of this drilling. So it's really quite, it could be quite harmful to the environment, if you will. Great economic opportunity, but at what cost? So we partnered with West Virginia University and put 2 grants in to the National Energy Technology Laboratory, and one was for the Whitaker shale, and one was for the Marcellus shale. So West Virginia led the Marcellus grant, we led the Whitaker grant. And these grants were awarded because look how unique, again, Ohio was for investigating these questions. So the main question, what is the environmental impact of shale drilling? So we ran into a little bit of a political problem, though, because Governor Kasich said, I don't believe in drilling on public land. So all of a sudden it was like, uh-oh. It's like, oh, shit. What are we going to do now? We get this grant. We get this $12 million grant. We're a sub on the $7 million grant, and all of a sudden we can't do it. So we begged, we pleaded, we did everything imaginable, and this was a philosophical thing about not drilling on public land. I wasn't happy about this. But I think we found a workable solution. So there is something called the Muskingum Watershed Conservancy District that is much larger. So here's our original site, right there. But there's this huge site that, for some reason, is also public land in my mind, but I guess it's governed differently. So it has a different set of rules. But these people that actually govern this huge area are quite happy to have us put one of these research wells. So the question is, can we put, what is the impact of a research well? So we're going to drill a research well and have that, and actually we'll have environmental measurements before drilling, during drilling, after drilling, and basically say what's the impact. So here's where universities, I think, have a real win, because we're trusted and we tell the truth no matter what it is. It's not a political answer. It really is a truthful answer that's actually borne out by the science. So really very excited about this whole shale project and the Global Water Initiative project. But again, the shale project can't answer it with a single department or a single college. It's not just the geology department, because we need engineering, we need geology, we need arts and sciences, we need medicine, we need all these different sorts of things. So I want to talk a little bit about the value of research partnerships and a kind of a very interesting project I'm not sure you're aware of, but Ohio is unique in its ability to our network, our broadband network, there are, we're all connected by 100 gigabits per second network. And this is through ORNet, which is located at Ohio State, but we're just a fiscal agent for this. But 10 cities in Ohio are actually connected with 100 gigs per second. So the average connection around the country is either 1 or 10, and that's considered really high capacity. So think of the opportunities. This is a research network. This is a business network. Tremendous speed. You can actually send information across these networks. So there's a site, isn't that where we are right here? So I think we actually, it runs right through here. I don't know if it's connected to here, but probably not. But so this is something that KSIC invested in through connecting all of these cities in Ohio. It's not just universities, it's K-12, it's hospitals, it's public broadcasting stations, et cetera. Sounds like I'm giving him an endorsement for president, doesn't it? He's going to be announcing in a international research programs. That's another very big research partnership. Ohio State's opened 3 gateways, and these are like mini embassies, if you will. It's not campuses. A lot of universities have put campuses overseas, but they haven't really. They've been some money losers. Let's put it that way. So these are just small offices, but they actually are a great place for alumni engagement, for research, partnerships, for teaching, for student recruitment. A lot of universities put these there for student recruitment. That's just one point that we use. But actually, corporate partnerships are another purpose that actually have been quite successful. So we opened one of these gateways in China, in Shanghai in 2010, in Mumbai in 2012, and then last year in Brazil, Sao Paulo in 2014. What I'm particularly proud of is some research grant partnership programs with Brazil that Brazil puts 1% of their tax dollars into research. And so that's quite unique amongst, foreign countries. And so they have made an offer to universities throughout the world, really. They've partnered with 100 universities or companies on a dollar-for-dollar basis to essentially do research together. And so we have the largest of one of these at actually $1.4 million. So we put up $700,000, and then Brazil put up $700,000. And so we just actually yesterday closed out a grant program, or just the deadline was actually yesterday, and so we actually ended up with 40-some grants coming in as actually part of this program. So it's just the Brazil flag. So I want to talk to you about some student partnerships real fast. And so this is the electric motorcycle team, and it's this is out of what's called the Center for Automotive Research, or CAR. And this is the Buckeye Current team. They participated in the Isle of Man Tourist Trophy competition. They ended up 3rd overall. They were the only collegiate team. And they ended up setting a record at 92 miles an hour, 92.5 miles an hour on this motorcycle. So we're very proud of them. But it's an interesting dynamic when these students come together, students from not just engineering, but it's students from arts and sciences, communications, political science, all over. So the Center for Automotive Research is exceptional at really bringing teams of people together. And this is another team that the Center for Automotive Research brought together. This is EcoCar 2. And this group ended up being the national champion of actually the EcoCar competition. And this is a really interesting 3-year competition of students. So this team was 15 graduate students and 30 undergraduate students who came together to work on this Chevy Malibu and to make it the most efficient, energy efficient car ever. And so this competition took 3 years. And so each year was a different goal. And I think they beat out something like 20 other universities. So they came out number 1. And they're judged. You can't imagine all the different categories this car is judged in. So we started the next eco-car competition, and this group actually won the first year of a 4-year competition, actually last month. And they're actually taking a Chevy Camaro and making it a high-performance hybrid car. So that's actually very exciting. And the last team is the CARE battery team. This is a team that won an Ohio State business plan competition, but then they actually also won a Department of Energy $100,000 award, a national award. So what did they do? They actually developed a potassium air battery. So not a lithium-ion battery, not a conventional battery, but a battery based on potassium and air. And so this was judged to be really so exciting and so innovative that it actually won them a Department of Energy award. All right, so lastly, how do we talk about research? So I think we talk about dollars received. You saw my first graph with dollars. That's an input into research. So when we talk about outputs into research, what do you think is, what's an output that you care about in research? What are you working towards in your projects? Do you want to have your name on a research paper? Okay. So that's an output. You want your name on a presentation, and like a national presentation at a meeting? Okay, that's an output. Okay. That's like your name on a patent, or that's a. So when I think of outputs, those are the things I think about in publications, in presentations, in books, in patents. Right? So there's another way to think about research, and honestly, I spend a lot of my time in Washington talking to the legislators, the Ohio delegation, and I'm not getting very far talking about publications and presentations and patents. They care more about patents than they do about publications. This got their attention. So what this is a project called U-Metrics. And it's basically looking at all the federal money that comes in to Ohio State. Doesn't have to be Ohio State, can be any university. And it's where that money is spent. So when you think you get a $100,000 grant, you turn around and you spend that money. You hire people. You buy test tubes. You buy, whatever. You buy round gobies. You buy all sorts of things. I guess there's plenty of those around, right? There's plenty of those. Okay. but you buy stuff actually for those projects. So those legislators actually looked at this map. So what this map is the expenditures from a federal grant, and it's where Ohio State spends that money. And so that really got their attention, because they could look at their gerrymandered districts and they could say, well, geez, so what I used this for, and it was really impressive, was it was for sequestration. If you remember, sequestration was going to be an across-the-board cut to federal dollars. And so by showing them this graph and saying, this is what it looks like today, this is where the money that you put forward, and we win, this is where we spend that money, take that down 10% and see what happens. Then what are you going to say to the person in Union County, what's this county?
Ottawa.
What do you say to the people in Ottawa County? So much to my surprise, I was looking at the darker colored counties. I was looking at where the most money is spent. You know what the legislators focused on? The white counties. They're like, well, why isn't there anything spent in Greene County? So like, because there's only cows in greenhouse, you know. So I was thinking, you know, 71 looks pretty good here, you know. So is this Ottawa County? This one?
Yeah.
That's Ottawa County. So it's not any Ohio State money going in Ottawa County. So, but this actually got their attention because it actually said, oh my God, for sequestration, I'm gonna have to explain to somebody why I'm cutting these federal dollars. So this is a way to talk about research. It's how we spend our money. So this is what the Ohio State expenditures look like from all of our federal grants. And notice they're not just spent in Ohio. They're not just spent just in Columbus. They're spent A, all over the state, but B, all over the country. It's a little weird out here because they have bigger counties out here. So it's not that we spend all our money in Southern California and Arizona. So this got people's attention, but it was very important that it was done by county. So U-metrics, remember that acronym. And another important thing about public outreach is it's really important to talk about our research. We actually have functioning labs at our Center of Science and Industry in Columbus, COSI. There's 3 labs there, and this actually shows one in the area of pharmacy. So we have these are big glass enclosed labs where students can they can watch research being done from the outside, it's all glass, or they can actually come in and take part in the research. So there's a pharmacy lab, there's an optometry lab, and there's also a language program lab. There's also things like a kidney transplant video. WOSU, which is a public broadcasting TV station, is located there. We did lots of science days there, and Ohio State actually does this in partnership with COSI. Things like Farm Science Day, Physics Day, Climate Day. We could probably do a harmful algal bloom day. So, and then there's also a science communication program there too. So things like introducing the public to various research ideas is actually also very important. So I'm going to end there and see if there's any questions.
I'm definitely not hip, so I wouldn't have known this until recently, but maybe the audience does. So, but for safety's sake, can you define crowdsource funding? And I'd like to know how you see that fitting into possibly OSU's research portfolio.
So crowdsourcing is actually it's really salesmanship. It's supreme salesmanship. So you put a very cool research idea out there, and there are sites. Kickstarter is one of them, and there's a number of companies that you can actually put a cool research idea around. But there's a lot of constraints around this. I mean, you have to, let's say some of the projects we heard tonight. You have to put a dollar amount on it. Let's say you want to raise $5,000 to do a particular project. If you don't reach $5,000, you don't get any of it. Or, that's the rule of some of these companies. So I think it's a lot of work actually for this. So it's a lot of universities have their development people run there. And I find that development, I mean, we ran into this with our own development people. They thought it was going to be a cash cow. And these are people who aren't donors to Ohio State typically. They're donors to that project. And they're passionate about that project. And I find that it's typically $5 and $10 donors. So is it the answer to declining federal funds? No. And it's a heck of a lot of work because, these people, they may give you $5, but they want to know every incremental advance you're making.
So reporting to the general public is funding you is
harmful might be offensive to somebody, you know? So I think there's a lot of headaches associated with it. Yeah?
So in our audience tonight, we have, and this changes every year up here, but we have students from a lot of other places besides Ohio State. A lot of them are some of the other state schools in Ohio or other small institutions. And I know this isn't really your job, but you sort of see the inside of it from a place like Ohio State. So I think research is sustainable at some of the small institutions.
Absolutely, I do. I think, though, that everybody is going to have to specialize. You know, I don't think that, does it make sense for Bowling Green to be a comprehensive research institution? It may not. You know, I think it actually may be, you know, perfect for certain sites. I mean, we're all doing this, though, to look at what are our strengths and what can we really go after that is an area of strength. I mean, we've actually done this all along in, you know, I mean, you might not have a podiatry program at Kent State, for example. You did?
Traded their baseball team.
Well, forget that example. You know, but there are certain areas you've made a decision not to have. You know, so I think all of us are going to probably have fewer of those areas that we consider our best. So I think everybody's got to really specialize and go after their areas where they're excellent.
No engineering.
What? No engineering. But I do think partnerships then become very important. You know, so that, you know, Kent State working with, you know, CASE working with, you know, Neo-UCOM around certain things. I mean, I think we're not going to be able to stand alone, you know, much more. You know, we're going to have to really work together, I think.
Just something I was wondering, like terminology-wise, is the shale mining, is that what fracking is? Okay.
That's the process by which you get shale. So fracking means horizontal drilling.
Okay.
So being at Ohio State, I understand the whole Discovery Things Up initiative, and I understand that the problems and the questions we're addressing now are so large in scope that it lends itself to that Discovery Things. But also coming from academia, that's hard for a lot of professors at universities to think that way, to do those partnerships and to bring on a hire that isn't just we're recruiting an ecologist for the department. Now you're recruiting somebody that fits cross-disciplinary.
It's really hard.
So are you seeing the faculty, for the most part, kind of embrace the discovery themes and see that that's the direction it goes, or has it been difficult for faculty to wrap their brains around?
It's been difficult. You know, and I think how it there have been competitions. There have been, you know, kind of competitions put forward for certain areas. And, you know, so faculty come forward with their proposals about certain areas. And so those are put in a, you know, in a big grant review cycle, basically. And so that has, I think that has unfortunately created winners and losers. You know, but I think that's something we're all used to. It's kind of a grant review, paper review cycle where it's all winners and losers. Yeah, it has been. But these are thinking this broad, but I think this is the way to solve the problems. I mean, the goal is attacking and solving the problem. And I think that's the way you have to do it.
I had one other. Go ahead, please.
So a lot of us actually in this group have actually been part of research projects before or are used now, and some of us have got research grants as well from Ohio State. And I guess myself included, I've never really asked if the Office for Undergraduate Research, do those grants for undergrads specifically come from a similar makeup of federal and industry, things like that, or is that kind of a different
So there's two, at least at Ohio State, there's two pots of money for undergraduate research. One is institutional funds. Those are sort of the, you know, the $1,000 grants that anybody can apply for. And then there are the grants that, you know, you get when you actually join a laboratory and you know, actually secure funds actually from a principal investigator. You know, those tend to be more federal funds. You get put on a grant that tends to be, you know, for a slightly more experienced kind of student. I'm sorry, what was the second part of the question?
I guess, how do you convince, or how, what would be the argument that those providers are using to argue that undergraduate research is really worth putting a decent chunk of that initial fund?
Actually, I think that's an easy argument, you know, because that's really the pipeline of future researchers, you know. So you're trying to, you know, we're trying to attract you into a career of research. You're trying to, you know, have that spark get turned on inside you. It doesn't happen with everybody, but hopefully those people are sparked to, you know, the people that, you know, it does attract, get a taste of it, they want some more. And so I think that's pretty well understood out there. So there's a lot of support, actually, for undergraduate research.
For Sea Grant specifically, we give out about $500,000 a year. And when professors or universities come to us for funding, the max they can ask for out of their total budget is 10% to go to the faculty members. The rest of it has to go to either equipment or supplies or supporting undergraduates. So there are some institutions or some funding agencies that will say there is a cap. Some of them.
I think another example of that is so yeah, they have REUs here at Stone Lab. They have a lot of you are working on now, but then NSF, research experience for undergraduates. So
Just to, so I'm not sure some of the students in here, when professors apply for a lot of these grants, NIH, NSF, what is typically the success rate historically relative to in this climate? What is typically the success rate?
I took that slide out of this presentation. At NIH, it was typically 20% in the best of times, 25%. It's now down to 10%. You know, so that's it's largely because of an increase in grants submitted. That's the reason that it's actually gone down. And grants have gotten larger. You have transgenic animals. You've got, you know, increasing costs of work done. So the size of grants and the number of grants actually have increased. Thank you. You've been a great audience.
So those on the phone that are on the webinar, so next Thursday is actually our REU presentations. So there will be no webcast or webinar next Thursday. And then after that we have, do you have the other slide for the next one, Trev? So it's Dr. Bruce McPheron is going to be our guest lecturer, who is the Vice President or the Dean of the College of Food, Ag, and Environmental Sciences, where Jay Martin does his work at. And I'm trying to think who the guest or the research lecturer is for that. Off the top of my head, I can't. So in 2 weeks from now, though, we'll restart the webinar series. Right. Great. Thank you for coming tonight, and good luck on Tom Simon's quiz tomorrow.